testing a proportion. So far, we covered testing mu, population mean. Now we're going to talk about how to test population proportion, P. Because we're testing a new parameter, population proportion, we must replace mu with a lowercase p in our hypothesis statements. We'll be still doing have a hypothesis value, but we change our test statistic, which is different formula right here, this one. Just like when we're estimating p with a confidence interval, we turn to z distribution. We're using z as a critical value. Okay. So the formula for test statistics is this, where the p hat is the sample proportion. So this is the sample proportion. So we obtain sample proportion, and we need to use that to find the test statistic. And everything else is same. Set up the statements, find the test statistic, p-value, compare the p-value with alpha value, and find the conclusion. So let's look at the example. A team of eye surgeons have developed new technique for risky eye operation to restore sight of people blinded from certain disease. Under an old method, it is known that only 30% of the patients who undergo this operation recover their eyesight. Suppose that surgeons in various hospitals perform a total of 225 operations using this new method, and that 88 have been successful, i.e., the patients fully recover their sights. Can we justify the claim that new method is better than the old one? Use the alpha level of significance 0.01. Again, always first set up the hypothesis statements. Now we're doing proportion, p. So we should write p here, not mu, p. Parameter we're dealing with here is p. Okay. And the old one had 0.3, 30%. Okay, old method at 30%. So it's a new method is higher than 0.3. Since in order to be better, that means it's higher than 0.3. And new hypothesis can be either equal to 0.3, also less than equal to 0.3. Okay. So looking at right here, we know this is right-tailed test. Right-tailed test. Okay, so let's find the test statistic using this formula. So, okay, let me highlight this one more time before we move on. We're dealing with the proportions. We must write p here. So the formula for test statistic, p hat minus p over square root of p times 1 minus p divided by sample size. So let me show you the formula sheet. From the formula sheet right here, we're using this formula right here. Hypothesis test for p, proportion. Okay. So let's find the p hat sample proportion. Well, 88 out of 225 were successful. So this is the p hat. And p value right here, p is 0.3. This value is 0.3. So let's write all these numbers for the z statistic. 88 over 225 minus 0.3 divided by square root of 0.3 times 0.7 over sample size of 225. And if you put this in a calculator, you get 2.9823 for z value. So test that is z equals 2.9823. So this is our test statistic. Now using this, we can find the p-value. Well, for p-value, since it's z, we're doing the same if we were to for the mean with population standard deviation given. So here we're finding p-value probability z greater than 2.9823 because it's right-tailed test. Since it's greater than, we can find directly from the table. We do 1 minus z less than 2.9823. 823. And we go to the Z table, 2.98. 2.98 is right here, 0.9986. This value is 9986. So we do 1 minus 0.9986. We get 0.0014. So our p-value is 0.0014. And fourth step, same question where we're always asking, is p less than alpha? Well, for this problem, alpha was 0.01. Is 0.00414 less than 0.01? Yes. So we reject H naught. Reject H naught. So let me write the conclusion. We reject H naught. So conclusion is there is sufficient evidence to support or conclude that new method has probability greater than 0.3, which means it is better than the old method. Okay. We rejected H naught, means there's enough evidence to support alternative hypothesis, H1. New method proportion is greater than 0.3. So again, the structure is very similar in all the hypothesis problem. The main difference are finding the test statistic and how to find p-value. But the beginning, the statements, and conclusions are very similar. Especially conclusion part is always comparing p and alpha value. So let's look at one more example. Woman athlete at University of Colorado Boulder have a long-term graduation rate of 67%. Again, just reading this 67% tells us that we're dealing with proportion. And also the word mean or average is not mentioned. Also standard deviation is not relevant in these problems. That's how you recognize we're dealing with proportion. Over the past several years, random sample of 38 women athletes at the school showed 21 eventually graduated. Sample size, 21 is success, X. Does this indicate the population proportion of woman athlete who graduated from University of Colorado is different from 67%? Okay. So again, always write the statements first, new and alternative. Well, alternative here is the proportion different from 0.67? Then new is 0.67. So this is two-tail. Two-tail. Second, we find test statistic. Here we use Z. For proportion, we always use Z. So the formula for Z equals p hat minus p over square root of p times 1 minus p divided by n. So p hat is x over n. In this case, 21 graduated out of 38. So this is the sample proportion, right? And p, we know p is 0.67. So 1 minus p will be 0.33. Okay, so that I can plug all these numbers to this formula. So then z equals 21 over 38 minus 0.67 divided by square root of 0.67 times 1. Well, let's write 0.33. We already calculated. Divided by sample size was 38 out of 37. Right? So if you calculate this, you get negative 1.54. We round to 2 decimals. So once we know the test state is z equals, again, z is important, not t, because depending on z and t, where we find the p-value is different. This is our test stat. So using this, we find the p-value. Well, this is two-tail. Since it's a two-tail, we find 2 times probability of z greater than absolute value of test stat. So in this case, for using our number, probability of z greater than absolute value of negative 1.54. Since it's absolute value, it will be positive 1.54. Take the absolute value of negative, becomes positive. And 2 times this portion right here is greater than, which is same as 1 minus probability z less than 1.54. So now we can find this value from the z table. Oops, sorry. Let me go to z table. 1.54. 1.54 is right here. 9382. 9382. 9382. So the p-value is 2 times 1 minus 0.9382. Make sure to do this subtraction first and then multiply 2. Then we get 0.0618. Multiply by 2, it gives us 0.1236. So this is our p-value. P-value is 0.1236. And we compare, is p less than alpha? Alpha for this problem was 0.05. Let me just double check. Use 0.5. 5% means 0.05, right? So is alpha is 1.1236 less than 0.05? No, because this is bigger. 0.12 is bigger than 0.05. 0.1236 is bigger than 0.05, right? That means we fail to reject. Fail to reject or do not reject means the same thing. Fail to reject H naught. So our conclusion is there is not sufficient evidence to support the alternative hypothesis. The proportion is different from 0.67. Alternative hypothesis. Right? Again, the structure same. In this video, we looked at how to test proportion. One main thing that changes is just this formula. The formula for z test statistic, we use this one. But the way you find the p-value is same as this portion right here, the way we did these problems, mean with popular standard deviation. Find the p-value depending on two tail, left tail, right tail. And the way we find the conclusions, compare p-value with alpha.